Thank you, everybody. It's strange. Without light, how could we describe anything? But of course, you can't really describe light or even see light, just the things it illuminates. I just finished reading a little masterpiece of scientific description, a book called Chasing the Light: The Entwined History of Light and Mind by physicist Arthur Zantz. I'll spell that for you later, which traces the long history of humans' conception of light and how it travels through space and the role that mind plays in perception. In the beginning, Zayant says, light was seen by humans as a spiritual force, really starting with the Egyptians, who viewed sunlight literally as the gaze of their sun god, Ra. And light and darkness, of course, are central themes in Judaism, Buddhism, Zoroastrianism, Christianity, even Satanism. Lucifer, after all, means bearer of light. How strange is that? Zayantz is interested in these early spiritual descriptions of light because, as a physicist, he's frustrated with the inability of modern science to nail down the true nature of light. This is the famous wave particle duality that bothered Einstein until the day he died and still hasn't been resolved. In fact, it's kind of gotten worse with quantum mechanics. But way back when, the Greeks were the ones who started the process of looking for material rather than spiritual descriptions of light and vision. To Empedocles, one of the pre-Socratics, the goddess Aphrodite created the eye out of the four elements to be like a lantern. The primal hearth fire of the universe was inside, protected by earthly skin and bones. It projects beams out through the watery eyes and into the air, where they encounter other bodies' beams coming at you. And when those beams contact each other, Plato said, thus we see. But what are those beams of light out there? As with so much modern scientific thought, Isaac Newton set the ground rules here, asking, are not the rays of light very small bodies emitted from shining substances? These bodies behave just like his famous apple and the earth, or any other body that obeys Newton's laws of motion. They're corpuscular objects, later called photons. They arrive at our eye, and thus objects in the world are seen as they really are, or so Newton thought. The conception of light as waves, on the other hand, started in the scientific imagination of Rene Descartes, the Frenchman, who conceived of a plenum of space filling the space between objects and eyes. And so light is not Newton's small little bodies, but it's the tendency of motion of that plenum. Sight is like the stick of a blind person. An object affects the plenum when it hits it, causing a concussion to the eye, and thus we see. With both conceptions, particle and wave, the eye and the mind are passive receivers of reality. But if what we passively see is accurate, how do you explain optical illusions? Asked the German poet and thinker Goethe. Perhaps you've had the experience of staring at a bright object against a white background, and when it's removed, you see a dark after image on that white background. In fact, Goethe was inspired to write his book, The Theory of Color, by seeing a beautiful woman across the room in a bar. Her brightly lit face was surrounded by dark hair. She wore a scarlet bodice. When she stepped away from the white wall, there was her image, still on the white wall, but this time with a black face surrounded by a bright nimbus of light, and she was dressed in magnificent sea green. Goethe wrote, optical illusion is optical truth. Edwin Land, many centuries later, was not a physicist, but the inventor of instant photography, which is now making a comeback. I saw at our last family reunion last weekend. He pushed the issue of mind's role in perception even further in a November 1957 demonstration to the National Academy of Science. This demo went beyond optical illusions and challenged the very Newtonian common sense idea that, for example, if you merge orange and yellow light, you get orange-yellow light. Land shone parallel lights through black and white photographic transparencies of the same still life scene shot through orange and yellow filters. With only the yellow filter projected, you saw a monochrome yellow scene. None of the original colors, just shades of yellow. The same was true when only the orange image was projected. Now, Newton would have you think that if you projected one on top of the other, you'd see a monochrome yellow orange image, but you don't, Land demonstrated. You see a full range of colors, including reds and greens and blues. Well, how the heck is that happening? What's going on here? Goethe actually called it the law of required change. He suggested that when the eye is stimulated by a color from one part of the color wheel, the eye seeks to complete the circle by providing its opposite color off the color wheel. So his lady's bodice turned from red to its opposite on the color wheel, green. Yellow and orange filters on top of each other yield lots of colors. Red, that's right next to orange on the color wheel. So that makes a little sense, maybe, but actually, you even see blue and green from the whole other side of the color wheel. Today's physicists call it chromatic adaptation, and Zant suggests that it means the Greeks were right. The mind has an active role to play in sight, not a passive one. Maybe the eye doesn't beam forth its own rays, as Empedocles thought, but mind is clearly active in seeing, not passive. And this jibes with the general quantum mechanical direction physics has taken that I've talked about here before, that subatomic particles actually don't really exist in Newtonian time and space the way we think of typical objects. They only acquire position and velocity when the mind measures them or when a human puts up a device to measure them. So the same is true of the objects of sight, as it turns out. They are what we actively make of them. And actually, the same is true of speeches using descriptive language. So let me ask, were you able to picture Goethe's woman in the bar or Land's demonstration in your mind's eye?
Yes.
Thank you.